Oh, cool. Somebody put the agenda on the website. Thank you, Vaughn. All right. Did everybody see the agenda? How about now?
Yeah, I see it.
Yeah, why
Okay.
don't you hit the full screen button on your Chrome?
Yeah, good idea. Well, I have maximized. I don't have full screen.
You hit F11 and you'll have
F11?
normally. If you're using Chrome, if you're using Firefox, then maybe not.
Now, this is Chrome.
Uh,
Oh, wow.
So Dawn and I found out today that you cannot record on Firefox. You can only do it on Chrome.
Okay.
Just for
Okay.
everybody's info.
So, let's do some hellos and intros. We have a new attendee, Jonathan Hunsberger, who is active with TriMbed and graciously took over the TriMbed web hosting and has made a bunch of improvements, which are ongoing. And he's expressed interest in the project. And why don't you say hey and tell us a few words about yourself, Jonathan?
Hey, I'm Jonathan. I just have picked up this embedded stuff as a hobby in the last 8 or 10 years, and I'm an IT guy normally. Hence the interest in taking over the website and some of this install stuff you guys are doing and whatever. So just trying to get an understanding of how it all works, and that's kind of how I work. I need to understand how it all works, and then I can figure out what to do with it.
Very good. Well, why don't we go around the real and virtual tables and introduce ourselves and provide just a few words to sync Jonathan up with who we are. Paul?
I'm Paul McDougall. I'm one of the co-founders of TriMbed. Been doing embedded stuff as a hobbyist for many, many years now. Haven't done much with FPGAs, and definitely not with analog FPGAs, but look forward to it.
So I'm Rob Mackey. I'm on the board of directors. Can you all hear me? Let's just check. Can you hear me?
Yeah, we can hear you.
Okay, so I'm on the board of directors of the Forge. I think I did my first embedded project when I was 12 years old with discrete components back in 1970 middles. And I worked for Cisco doing network stuff while I built things like electric cars for fun. And now I work for ShopBot Tools doing their next generation motion planning software. And I still play with robots. I guess that's me.
Okay, I'm Pete Soper, and I started up TriMbed with Paul. We had our 10th birthday last October. And I'm on the board of directors of Splat Space, and I'm a Force member. So I got involved with computers. Well, I programmed a CNC machine at IBM in 1968, paper tape, and then I had nothing to do with anything until 73. I was involved with some research, and we started having more data than we could deal with. So the principal investigators sent some of us off to learn Fortran, and by the within just a few years, that became more interesting than my degree work. And I joined a little mini computer company, and about 2 startups later, I was making embedded operating systems RTOSes for communications products. And fast forward through more more startups and OEMs. I left Sun Microsystems in 2008 and took a long vacation and decided, okay, what was the most fun thing that I did? And the job at Network Products doing embedded was the most fun. So I decided to get into that and hooked up with Splat Space and Paul all at about the same time. And so that's, oh, and then I found this guy, and he found me. He started attending friend meetings. And,
There were snacks when I attended. There are no snacks. This has really gone downhill.
I know. I've still got some drinks in the garage, and I expect to be able to resume the drink service in a few weeks, a month or so. So anyway, that's me, and over to you.
Nick, I program computers, and I have a little company modestly called Edgington Labs that does whatever I feel like doing. I build little things, tunneling electron microscope. I'm doing research into graphene and boranes, which are graphenes made of boron. Boron chemistry kind of being interesting. I enjoy doing things that I am completely unqualified to do. This being one of them. That's me.
Okay, I'm Dawn Trembeth. Background, a little bit of hardware, a little bit of software, a little bit of biotech stuff. Interested in embedded system stuff or sensing things about plants and microbes currently. And just thought this sounded like a really interesting project to get involved with.
So who online first? Carl?
Yep, my mic was off, sorry. So yeah, I've been involved in electronics for like years. I think I built a cat whisker radio back in the late 1950s, early 60s or somewhere around there. I continued playing around with electronics and then and was in that field for a long time, had a service shop, used to fix all sorts of stuff, started fixing computers, the old Ataris and Commodores and whatnot, video games. Around 45 years ago or so, I started really writing code. Probably about 40 years ago, or maybe a little more, I actually did it commercially.
Oh, I know what it might be.
Yeah, that's on that side.
Okay.
I worked for many different companies.
Fine.
I worked for many different companies. Cisco was the last company I worked for, SecOps, security operations. I architected and engineered a security API framework for determining who can log into what server all around the world. Up until that point, any engineer could get into any machine pretty much anywhere in the world except China and human resources. So, yeah, I've done a lot of stuff. Hardware, I also did work for NASA with hardware, built telemetry switching systems. Geez, I was in my late 20s when I did that. So, yeah, I've been around doing this stuff for a long time.
So Haven, do you want to? I'm just going across the screen.
Oh yeah, sure thing. Here we go. Introduction. My name's Haven. Let's see. I guess in terms of life, we're just starting in terms of IT. Uh, I guess I came to North Carolina. Went to Hillside High School. Graduated there. Worked with Pete. He taught me a lot about electronics and programming. Then I went to college for IT and graduated with a bachelor's, and now I'm working at a community college. That's me. So I joined this project. I was interested in programming FPGAs, and I wanted to improve my electronic skills. Yeah, that's me.
And I think that means, is there anyone we haven't gotten to yet?
Jamie.
Oh, Jamie, I'm sorry, Jamie.
Hi, I'm Jamie. I'm a student at Wake Tech, working on an embedded systems certificate. Currently studying C++, and I'm looking for internships. And I'm volunteering at the Durham, actually it's Triangle E Recyclery currently, and badgering the Warp Computers guys to see if they'll take me on. So, and then I'm just trying to follow along with what we're doing here.
What Pete has,
I'm configuring my project board to talk to the forged Wi-Fi, and I was intending to do that while Nick talks. So
I will talk.
let me go back to the thing. So the key part of the meeting is to do with demoing the new major release of the Etcher system. It's in a demo state, and then we'll have Q&A and discussion and so on, and then we'll talk about next steps, and especially we need to reconnect with users and start getting feedback, and specifically we want to request applications, and so prime the pump. Nick's going to be showing either showing something or showing a capability, and if there's time at the end of the meeting, I've got something that I can demonstrate. And then let's see, I'm just going to go quickly through here. And then if there's time, we'll talk about expanding to other communities. That's it. That's the agenda. So I'm going to disconnect screen sharing. If I can figure out how to do that. There. Over to Nick.
oh, me?
Yep. Ron.
Okay, I just,
Ron in two places.
okay, that's exciting. I've been, the Edger is a RESTful interface. It makes standard HTTP calls from a web server to an ESP, and by setting up various endpoints, you can request data and display the data. And Pete has been working, the core stuff runs currently on the ESP, although there are provisions for Raspberry Pis and other things. It's all written, the ESP side is written in C and C++, and is relatively small. The larger piece of code runs on the host and is running JavaScript with dialect called VUE, which is JavaScript is a mess and VUE can be very painful. It's a fair amount of code.
You said 30,000 lines.
48.
48,000.
it's a big piece of code. Not all of it. There's a whole bunch of vestigial code in there that I have to peel out. What I have been working on is a reasonably sensible user interface. It could use some improving. Um, the point I'm at is that the a user can get a relatively small piece of code. The whole edger thing, the whole aardvark thing is you don't want to go there. Um, but it is possible to get a very small piece of code, write an interface in that small piece of code to the AMP, which is the ESP, um, and then very easily fold that small piece of code into the larger system. This is done so um, OEMs can, who want a particular interface to a temperature sensor, I've got pressure sensors, plant sensors, they can interface, they can very quickly get a prototype up and running. The hope is that they will like us and give us assistance, but the code itself, what I will be releasing first, hopefully next week, is a very small toolkit that will allow you to play with stuff. There is the ESP side of things is a virtualization of, at the moment, the I2C bus. However, it is very easy to extend, and there are extensions in there which will gather temperature data and graph temperature data. At the moment, it's sort of stubbed out, but there was some interest in being able to graph temperature. That's sort of a very easy demo thing that people can start to play with. Let's see if I can show this damn thing. How do I do screen share? Okay. Okay, here. Undefined home. Yeah, that's okay. Share.
Put your mouse,
Ooh,
there
righty.
you go.
Okay.
So is that Chrome?
That is Chrome.
Hit the maximize,
Okay.
and then hit Control Plus a few times. See if we can get this.
Okay. Cool. This is exciting.
Now, yeah, it looks like it's showing everything.
Okay.
Yes.
Um,
Can everybody see that okay?
what this page does is you have to set the network address of your Wi-Fi into the ESP, and obviously your host has to be on that. Using some tricks, the system scans, and you can have as many ESP devices as your little heart desires. They'll all be listed here. I only changed the network address on one of them just because that's what I felt like doing. It returns the various immediately this page, and if you have other ESP devices on the network, it will return more information. Um, what This page is a result of scanning and finding that port, which is kind of tricky because you can't do DHCP, you can't do pings from, but it finds whatever board you're out there. It returns various information about that board. So this is some of the information, free memory, it's whatever else. Compile time, it's information that If you have a Raspberry Pi here, it will return Raspberry Pi. I've done some playing with that. If there are innumerable flavors of ESPs, it returns what flavor the ESP is. Just basically gives you all the information that you would need to write code. Let's see if I can cancel out of this. Okay, so these are the devices you have, and you can connect to any number of. Well, you can connect to a number of devices. There's a concept of a friendly name which is internally assigned board ID or whatever else you want. So you've got two menu items here. You've got the information which I just brought up, and with any luck, I can connect. Ooh, okay. This page you have the various interfaces that the ESP has. Not all of these are hooked in. You've got not behaving well. Okay. I do minus. Okay. You can do.
Do you need that much? Because they can no longer see it.
Well, I can do plus plus. My memories aren't working when I do. Okay. You can do various things from this page. It will basically scan the I2C bus. You can set the I2C parameters. You can do, this is the configuration for the interfaces that the I2C has. In this particular page, you can set via the, you can set GPI pins. You can set a pin, you can read a pin. In this, these are all the interfaces here. You can read, write, you can also program the dialog chip. So you've got, these are the interfaces that I've been playing with. And it's got a few, it doesn't tell you which device it's connected to. There are some fun things that need to be fixed, but at about noon today, I was thinking of hiding under the table, not coming to the meeting because nothing was working. I finally got things so that I'm reasonably happy with them. And these pages here, if you were to write an interface for a temperature sensor, for example, you simply write a piece of code, and by declaring it in a particular way, you can have it come up as one of the menu items, and it will display the data here in whatever format you happen to want. So you have all sorts of. Okay, let's see. Okay, you've got some passcode stuff because you need that. I got to restart it. And you've got the ability to set the navigation, do all sorts of personalization things. And I'm getting kind of happy with this. What I need is Pete's going to write a temperature interface. I'm going to get people to download, which I hopefully will be ready next week, the toolkit, and start writing interfaces for your favorite devices, which I can roll into this. I don't, if you've got laser rangefinders, whatever you happen to have, the way the core code is hairy, but the net result is that you have you can drop things into it very easily, and that's so it is relatively simple to use. And as I say, the example that I'm going to distribute is the temperature sensor, which shows and graphs temperature data. And it's a complete self-contained module. It doesn't have any of this stuff around it. So you don't have to understand what my pen scratchings do. All you have to do is you have to work through a JavaScript or a C++. You can the temperature probe, for example, which runs on the ESP, produces it's a custom interface just done for temperature. So there's an example of how to create this custom interface, how to get that data into the machine, and how to display the machine, how to display the data. And it's next week I'll get Pete the initial copy, and then when as it develops, you can ask Pete questions. Don't bother me. It is I sent a message to Paul. What I would like to do is at the next Try and Bed meeting, give probably the beginnings of a couple tutorials on JavaScript and VUE. Just the structure and how it goes together, because it requires some understanding of that. But it's so you can.
Let me add one detail.
Okay.
The reason that Nick needs to make these transitions is he's taking a graduate course at NC State, preparing a paper on some hairy material science subject, working with the plant people on photosynthesis.
And I'm going to Asheville to Pete
going to Asheville
to get drunk.
Yeah, we're going to see how much zero alcohol beer we can drink.
Oh no, I'm not. You drink zero alcohol beer. I don't drink zero alcohol beer.
Well,
You might have to carry me home, but
No, but in all seriousness, Nick has got his thumbs and toes in new stuff, and he's reaching a point where the infrastructure is becoming highly usable, plus or minus a few bugs. And so that's a bit of background of why this is a very important transition.
And it's to the point that other people can start to play with it. I finally, at about just after noon, dropped one of the modules that I'd written that Pete's been playing with, dropped it into the code, and it all connected automatically. And I said, hey, this is good shit. And I dropped a couple more modules in, and they all ran. And I was flabbergasted. So it's I could not figure a way for someone to share in the writing of the core code, largely because I only had a vague idea what I was doing with the VUE stuff. I'm a little more proficient in that, and prepared to teach other people how to do that. I will share the code. I mean, it's going to be out there, but it's in places it isn't pretty, and hopefully at some point somebody will be involved in making it pretty. I don't do pretty code very well, but so it's pick your favorite interface. If you want to put an LCD display on the thing, if you want to put an e-paper interface, temperature sensors. This is something I've been toying with. It's a underwater depth. It records the depth of water in a well over a long period of time. It uses an ESP. Right here. Okay. It uses an ESP battery powered. It will run for a year. on the battery. It goes into the sleep mode, wakes up, has a number of other kind of nice features.
Doesn't
This-
that pill bottle leak a little bit?
Well, the pill bottle is just so I don't pull the wires out.
Right, it's supposed to be immersed in water, it's got a pressure detector on it.
Well, no, yeah, it's got a pressure detector. The
It needs to fill with water.
what?
So it needs to fill with water.
Well, you're
No.
it's encapsulated.
Yeah. The way that this works is that the whole thing is encased in a block of epoxy, basically,
Okay.
and it has a Wi-Fi charging, a wireless charging unit. When you put it on the wireless charging unit, it wakes up and goes into the wireless mode, dumps its data to whatever you have for a host, and then and charges itself. And then when you take it off, it shuts itself down and takes data every however often you tell it to. If I encase this thing in epoxy, I can't get to it in Flash code because there are no
Well, that's not Wi-Fi.
there are no
There
there are no ports on the thing. And the only thing is the pressure sensor that goes to the steel tube and the embedded Wi-Fi charging unit. There's nothing else to get to it, and I'm not confident enough with over the air. So this is designed for being able to monitor water levels in coastal plains. I have one that monitors the light and salinity that hits a forest. So you can look at the saltwater incursion into a marsh. I've got a whole bunch of devices that I want, which is why I wrote the thing. I wrote it for me. I'm willing to share, but I wrote it because I want to do these things, and the best way to get that was to involve other people. I couldn't do it alone, if only because other people guilt me into saying, not drinking a beer on Friday night, but actually writing code. It's I need and this is good enough at this point that I want other people to play with it. That's my story.
And to add one more detail, those of you that read the lead traffic today probably saw my little one-line flow thing of requirements feeding into architecture, feeding into implementation. And then I forgot, so we got a user, and Nick's been user one, so he's made this thing for himself. But Nick thinks in terms of extremely general solutions and very, very, very general, like to the tune of 48K lines of JavaScript, and who knows how many lines of C++. And so that's kind of how we got here. We have been giving him some feedback, and I think that's turn on the agenda again.
It's getting to the point that it's fun. If you'd asked me that at noontime, I would have been very upset. But it is, when I started dropping pre-written modules into the thing, it's like, holy shit, this is fun. This is, I can create it takes care of all of the connection stuff, all of the file drop. And I dropped this program that I'd written months ago into the thing, went click, 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 and it connected. And it's like, something is going to go wrong. I made some big mistake. But but it's getting to the point that I want to share this. It's fun.
So it's going to take me 4 weeks to get there, but what I'd like to do, if it's at that point, is I'd like to find if there's anyone else who wants to get on board with me and develop 2 or 3, and they may just be stealing yours, 2 or 3 very well-known, like cookbook versions of things we can do with this, like what you've just described, and then offer at the Forge Wednesday night evening and it doesn't have to be for Forge members. It can be at the Forge. Like come in, and I want each one to be skilled so that in one evening you can go from soup to nuts with help without any strain at all. Right, so they have to be really small. They maybe blink a light kind of thing.
Yeah, but it's that's
Hey,
why.
we got that. It works.
Right,
It
right.
works.
So that's the very first one I'm imagining doing, and then practicing it, betaing on some people and finding out, oh, they can't do that in the evening, and here's why. With people who are willing to fail, until we get to the point where that's a thing that can happen, right? Is in a 2.5 hour evening or 3 hour evening, people can come in and walk away with sort of like you do with an Arduino, right?
Yep.
Let me show you how to program an Arduino, and they walk away having spun a motor and blinked a light, and they're like, "Whoa, I'm so great!"
But
Right?
the Arduino for me was I could not produce production code on an Arduino.
But that isn't right. The point is,
No,
with an
the
Arduino,
effect
No.
creating
I-
Arduino
right? But
app.
I can bring someone in, and they can blink a light and turn a motor and go away, and they feel very good. I want to get to where I can do that with 3 or 4 things out of this.
I want to get you to that. This
Right.
is
So
getting,
that's to me is the next big step.
this is beginning to make me smile.
Yay!
And
Yay!
that's, it's a smiling Nick is better than a grumpy Nick.
Because if we can do that, then
Yeah.
then those people can come up with ideas later, right?
And it's probably, weeks away, but not months. I want to show this to analog devices. I want to show this to dialogue. It is getting to the point I'm not embarrassed by it.
That's a good sign.
Yes, and that's, that is, things happen, they don't always happen the way I want it to, but, it's good shit.
Cool.
And I'm getting excited again. There was a point, where I was like, oh shit, I gotta get back and, sorry for the swearing, but hi ho. I didn't understand the code I've written. It just, I was just not into it. And I finally broke through and made it work. And it's like, I was, I was on the right track. And that's,
And to add another detail, because he thinks in extremely general terms, he wasn't happy with ITC, right? He need GPIO, and then we're gonna obviously need SPI, and we're gonna obviously need X, Y, and Z that weren't even in his demo. So, fanning this thing out to its full capabilities will be a process over time, but we've got something to start with, and we want to turn attention to users. And Dawn sent some wonderful stuff today about her experience with Windows systems. What was it called? Windows
WSL2.
WSL2, which has got Linux in the name. It's got
Support
Yep.
for Linux.
Yeah, and
Windows support.
Windows support for Linux, take 2. I guess they're past beta, right? No, they're probably still in beta. Who knows?
It's a different thing, actually.
So, she basically was only able to get part way, and is we're thinking through, how she's going to make more progress with that. We started with a very Linux. I have a new hobby now. I'm running a PDP-11, all virtual, and so I might say Unix when you're in that. I'm running a very old version of Unix. But we've been very Linux centric with this project, and we think we have a path to Windows support and Whistle support and OS X support. And it's in 2 parts. Part 1 is the fact that the code that is currently running in the browser by virtue of accessing a execution of a thing called node.js on the person's PC can be seamlessly and transparently replaced by an instance of all of the same JavaScript and other whatever other magic is involved, fetched off of the Edger.app website. So it's very, very straightforward to put all of that stuff on the website. So then,
Completely platform independent. You can run it on your cell phone.
yeah, so Windows users, or maybe even cell phone users, can trivially run the app. And the second part is that currently there's a dependence on futzing with AND. And that's going to go away. It will soon be, let me back off. And at some point in the future, no promises about when, it will be possible to configure your board for arbitrary Wi-Fi parameters. And that basically is the only thing that a regular user currently has to do. They currently have to, in order to run the existing system for what it supports, they just need a way to get the Wi-Fi bootstrapped. And we've currently got a scheme.
And the JavaScript code that runs on your cell phone or whatever automatically finds the devices. That's what I was showing in the first page. It goes out and JavaScript is not allowed to do network searches. It's not allowed to do pings. There's a way that this thing finds whatever boards are out there, finds multiple boards, communicates with them, and gets information. So there's no configuration that is required.
So basically, when I said months and months, a year ago, I asked, can I run this on my Raspberry Pi? And I was beginning to go down that route with the IDF stuff.
Yep.
Basically, at this point, I can run it on my Pi because I can do exactly what you just
You can run it on
described.
your cell phone.
Right. I can do what you just described and run it on my Pi, and I'm good. I can't.
I got a question.
Sure.
So you want to run all the node stuff on the try-embed server, is what you're saying?
No. You point your browser to the try-embed server address, and you left-click it, and it slurps everything down into your browser, and it's functionally exactly the same as if you were running node.js on your PC and connecting to local host. It's exactly the same.
Oh, so what you're saying is you are actually pulling all the JavaScript into the web page on your browser and running it through the browser.
Yep.
Yep.
Instead of Node.
Yes, that is correct.
Exactly.
Okay, so you have a one-time or maybe a multiple hit call to the try-embed server.
No, it's the Edger.app server, but carry on.
Yeah, right. Okay, well, whatever the server is, you have one or a few calls to that. So that's not that hard to make secure. But if you're going to run an API, then that becomes a security nightmare.
Yeah, no, it sucks all of the JS code down to the machine, runs it locally. There is no interaction with the machine beyond that. So yeah,
Okay. I mean, the idea sounds interesting. I'd love to see it in practice, but
We actually ran it. We demonstrated that at the last month's meeting, and it's in the recording.
yeah, it works
Yeah, it works right now, and
remarkably.
it's a side effect. It's a trivial step that has to be put into the build process to simply spit out that directory as a side effect of the build. So it's an additional run of PNPM, and then you just literally SCP the directory to the server, and you're ready.
And you can download the entire app from the server, put it on your local machine as a saved web page, and run it from the machine.
Ooh, caching.
Yes, it will cache and run directly from your machine because Google Chrome is smart enough when you click it on it as a web server, as when you download the file, that sits in a directory and you can run it from your machine. There's no particular need to be able to connect to anything.
So you only have to go to Edger.app anytime a release is changed.
So I think that the core functionality here is the browser interface with a thing, right? And
Yeah.
and so it seems like it really never needed the node other than to serve up files, and because that's like the way that you developed it, right? Like the
Yes.
REST calls were always going between the browser and
Yeah.
the device, and this is just a matter of how you're serving up the files.
Yeah, this is
This debugger will run a node. It won't debug something on Edger.
yeah, and I need to be able to set breakpoints and all of that happy stuff, which I can do in the tools that I have. But it is it will. I could give you the files right now on a flash drive, and it would run from your machine with no web connection.
Because effectively, it's an application that runs on a browser.
Right.
It just happened to have been served up from a node before.
Right,
But
and that's how it's built.
But looping back, when some of us engage in development, then the natural mechanism for that will be to use a local instance of Node.js for the reasons that we've mentioned. And it's a lot easier. In fact, I don't know about you, but for me, the cycle time between I've typed edits into a file and saved it, and now I want to see it running. I'd like for that to be about 5 seconds. 3 would be better. And to do something that involves Edger.app, forget about it, right? I mean, so we'll still have the dependence on the Node.js style of execution, and that will remain Linux-centric until or unless we get Windows users and Mac OS X users who are interested in investing in figuring out how to make that work. But getting back to the end user, I just want to use the functionality that's their user. They will not have to think about the expressive IDE. They will not have to think about Node.js, let alone JavaScript. It's just a browser interface that gives them functionality.
But don't you have to get the ant code or onto the ESP in the first place?
Yeah,
and let me just answer that question. Yes, but when we have made this planned change, once you get it onto your expressive board, your ESP32 board, the only thing you ever have to do is mutate the Wi-Fi parameters. If you want to get a new release, then I would direct your attention at these three.
Well, and
Hold on. Let me finish. These 3 desktop icons on a Linux system, which is available from a thumb drive. I don't have it in my pocket, but I could show you very, very slowly a thumb drive booting, and it brings up exactly this interface, except I'm running Ubuntu Mate, and the thumb drive uses vanilla Ubuntu. And it gives you these 3 desktop icons. So you've got this change Wi-Fi, and this currently takes your Wi-Fi parameters, rebuilds ANT, reflashes the board, and it's just a turnkey situation. But in the future, this will go one step further and completely avoid any kind of rebuild with ANT. So ANT will only have to get reflashed when there's a release that the user looks at and says, oh, it's got this feature, I want this feature. And then through a process that we haven't defined, they get their board flash
Well,
and carry on.
The
I'm
pro-
talking
the-
about end
yeah.
users, not.
yeah, no, but the process is that aardvark does over the air flashing.
Well, okay, but that is a
Not-
lot
not-
further.
No, no, stop that.
Not a raw ESP32s that don't have an OTA something in them.
Yeah, you've got to, you have to have the code, but it will do over the air flashing.
But let me bring our feet back onto the ground. This procedure to get rid of the build has been a requirement for approximately 6 months. And we haven't done it yet. The OTA is going to take longer. So, yes, the eventual mechanism that people will use to update their board will be over the air and even cooler than what we've been describing.
But they can't buy an ESP32 from Amazon and expect it
No.
to work.
That is correct.
That's
They-
Somebody
right.
has to download that first
Yeah.
version of CAMP for them.
Yep.
And that has to be done over a serial port.
So,
That would be done at a workshop or something, or some instructions somewhere.
right, so I don't, well, we would have to fiddle with the camera to show you the white, oh, well, we've got pictures, very close-up pictures of the whiteboard at https://edger.app. And you can see a, oh, in fact, I can just show you that.
But
There is the current standard development board consists of an expressive integrated ESP32 C3, which is a RISC-V ISA chip that's got the Wi-Fi and Bluetooth support, and it's got a decent power supply that's not going to fall over like Chinese Depot, Amazon, other ports. And it's extremely high quality. And then we've been using a Renaissance FPGA board. It's a mixed signal digital and an analog board. And currently we have an incredible app that causes this yellow light LED flash. And there's another LED that's the picture. This is cropped, and there's an LED right up here. It's just a very, very simple starting point. We do plan to eventually make full custom PC boards. We made two. A version 0.60 and a version 0.70, which when Nick's talking again, I'll put a picture of those up. And in a nutshell, we got ahead of ourselves, in my opinion, and we didn't have the involvement of others to really glom on to those PC boards and be able to say, well, this is wrong, and this doesn't work, and we need this, and we don't need that, et cetera, et cetera. So I'm looking for the requirements to expose themselves. Just for example, we think it would be very good to put the analog devices, what's their I2C interface called? PMOD. The analog devices PMOD interface would be really great to put standard PMOD connector on that board. It would probably also be really good to put quick connectors so that people can plug in Spark, Fun, and Adafruit and other standard peripherals. The temperature sensor that I will
also has a
pardon?
SEED.
SEED,
Yeah.
SEED, SEED also offers quick. Okay.
It's a different connector.
Of course. Well, and I have to say, the connector used by Quick, by SparkFun and Adafruit, is an absolute B asterisk to work with, in my humble opinion. I'm really familiar with that connector, working with a client for a while, and you'll break off your thumbnails to get this silly thing unplugged. There is a new generation of that connector that is trivial to unplug. It would be really great if SparkFun would and Adafruit would transition. But anyway, where was I? Getting back here to the steps that you currently can use if you just got a setup is you set your Wi-Fi and then you run this. You double click on this icon and it starts the Node.js server and what should I talk about while it does that? What did you have to say?
Oh, I run a something called WebStorm, which is a Node.js debugger, and it's live code. If I change a character in the editor, it changes immediately on the screen. It's very impressive. It's it makes life a pleasure.
So this is the current released version of the software, and I clicked on the third after I saw that the Node.js had finished coming up. So I clicked on the third icon, and it brings up the current released version of Aardvark. And as you can see, it's got some things that will look familiar from Nick's demo, but it doesn't have the much more general setup to discover devices and interfaces and so on. But what we plan is to eliminate the dependency on all of this stuff and change it to a bookmark. And in essence, after you have configured your Wi-Fi once, the steps are to plug your board in and go to that bookmark in your browser. And that bookmark can be a local copy, as Nick described, or it can get a fresh version off of the Enter.app website. So that's where we're at currently, and we've also described the near-term next steps, and then the further out next step of bringing over-the-air updates into the picture. We've got unsolved problems of when, as Paul was saying, if you bought something off of Amazon, how do you get started? And that'll be an interesting question, just problem solved. You don't need all of this other stuff that I described, that I showed on the board here. You don't need, your app goes here. And
Your device, whatever,
yeah, your app's hardware goes there.
So can I ask you a question? I thought I knew the answer to, and I probably do know it, but I've forgotten it. When you're doing like an Arduino, there's AVRDude that just lets you download the image to it.
Right.
Is there anything like that for ESP32 that isn't the whole idea? I feel like there is.
Yeah, there is. It's
So-
just using this single package you can download.
At which point you need to be able to adjust the binary to your Wi-Fi, and then a person could just image their.
Yeah.
They could pull an image, adjust the image, or provide the image whatever it needs so that he kind of knows the Wi-Fi, and then just stick it on the ESP32. That would be a way a person who goes to Amazon can get started without all the infrastructure. And when they're happy and excited and say, "I want to do this," they can begin to learn from the rest of the stuff.
Right, that's a great point that the installation process really is going to be not one size fits all. It has to deal with this would be an ideal, very, very low, lightweight,
Who are you? What
fast,
are you? Right.
simple thing for someone. And then we've got the next round um, where they get involved with the using the Express IDE, but they're still doing simple stuff, and getting the system away from developer world.
Away from me.
Well, and me.
Well, make it so that a person who really just wants to find out if it's relevant at all to what they're doing
Yes.
can easily say, I bought an ESP32, I bought a something, maybe I got one of
Well,
these.
You've got something that we've demonstrated.
Right.
So we've got a YouTube that shows you how to use
And
this.
then I put the image on, I hit the server and got the cached web page, and I'm in the business showing my lights blink. Okay, that's cool. Now I'm willing to invest the time and effort.
And the whole, although the code isn't quite there, is that SparkFun for all of their little devices has a module, which is, you just download the module
And you
and
got that.
you've got, so any of the SparkFun stuff, any of the Adafruit stuff.
Once those people start doing little modules, then that gets really easy.
Yeah.
And it's relatively low friction to do that with both Adafruit and Spark.
Yeah.
They're eagerly looking for ways to sell their quick / I2C boards.
Right.
And they've got pointers to various ways to get them working. So we think that we've got something that would be potentially of great interest to them too.
And the late loading of the modules should, although it doesn't quite work that way currently, is that you simply throw the Adafruit module for their motion sensor into the directory, Linux finds it and goes.
Yeah.
You're off.
Yeah.
And it's so it dynamically links at runtime.
And your browser just reads in those files too.
Right.
So so for the thing I was talking about, in some number of weeks, starting to practice, and then eventually in some more number of weeks, actually have people come in. I imagine that's the first blush they're going to be interested in. I don't want to understand this, and I don't want it to be complicated. I want to do some things and see some results. So if I see that, then I'm interested in coming back. I
want to do something. I want to make it wiggle.
I want to make it wiggle, and it shouldn't be too hard. And if I can make it wiggle, then it's worth more than the rest. Now, there are people, you get a call or you get a meeting, we're going to say, sure, just show me where that yes stuff is.
Yeah.
I don't know, maybe I can't speak for you all, but I was happy enough to do that.
Yeah, but and one of the things in addition to getting the blinky is to get a little servo motor, a little
Or read a sensor.
It's a
Where in the heck are the pictures?
Right, lots of little things you can do that just.
Yep.
Right, and then the thing that I think is words. So a thing that for years has been an issue with people who are new to all this, which is the audience I'm thinking about. I'm interested in getting people excited who never thought they'd do anything like this. Here's a question I used to get for years was, so what is the difference between Arduino and Raspberry Pi, and why would I use one or the other? And so here it's, why would I use an ESP32 or an FPGA for cache states? And so part of it is, at the level of Blinky, there is no reason to pick one over the other. They all blink. But having a couple of demo things, like you got, in fact, that sort of call out, well, this would be really hard to do if you use one of those in some way because this is better, right?
and frankly, I've run a version of the ant on a Raspberry Pi.
Sure.
It just the system doesn't care.
Right, and again, it's fine, but the idea is to then use it to have an FPGA or some other peripheral that's interesting.
Right.
And so having some of those where those four models, the first one's a Blinky, always a Blinky. And the next one, move some servers or motors because that's really cool. The next one should really grab something that if you tried to do it with an Arduino or with a Raspberry Pi, you'd run into, wow, that Pi uses a lot of current. Wow, that Arduino is harder to access, doesn't have Wi-Fi, whatever it is. This one actually is good to do with this system,
And
right?
you know, and the Arduino at the end, you have the text screen that comes up with, you know, it's
Yeah.
you know, you can't deliver code
Right.
from an Arduino.
Right. Well, what I meant is if the Arduino is the end unit, you still can't deliver a nice display. All you have is serial.
Yeah.
So right. So the point is to show that off.
It's the, oh, okay. That was a half-baked idea, if there ever was one.
You're going to use I2C to blow up an M80.
I can't find, there are really decent pictures
Oh, you want to show the circuit board?
of the custom boards, and please continue talking amongst yourselves. There it is. All right, so it doesn't actually fit on the screen.
Is it a control minus problem?
It's chopped off. Oh, I have to scroll it. So I have to make this smaller. That doesn't help. Anyway, this is the version 0.70 board. And basically this is a very, very small expressive C3, ESP32C3 single processor RISC-V running at 160 megahertz. And real low power. And it has thanks to expressive, you literally cannot tell that it's using a different instruction set architecture. The tool chain is so beautifully designed and executed that it's trivial to switch back and forth between vanilla ESP32s and the new generation. And the latest word is that ARM wants a lot more money out of their licensees, which is going to do wonders for stimulating RISC-V usage all over the place. So anyway, this is the funky mini USB connector, and it's a decent power supply with lots of current capability and some buttons, or two buttons. So I think, where is the other one? Oh, the other one's on the other side. Oh, there's another button in there. And here's the, this is kind of cool. There's a 10 by 4 set of female header sockets, and when you're using the pre-made FPGA board from Expressive, and by the way, these are ridiculously cheap when you can find them, and it fits into the inner 2 rows of sockets. But there's also an Expressive, which I didn't bring, and someday I'm going to get my document camera to work. It'll be like over at NC State, where you can throw something underneath the document camera, and that'll be very cool. But for now, it's really hard to show these boards on our the camera setup that we've got. But Expressive makes a killer development board, and it plugs into the outer 2 rows of this same connector. I don't have all of the connectivity worked out, but I believe that it's feasible to support this. But we've been talking about the whiteboard quite a bit, which is designed to be fall over, place your Amazon order. If you're smart, you go to DigiKey and get be $10. Expressive board, I don't think you can get that. You might be able to get it off of Amazon.
Yes, you can.
Oh, good. So you could buy the board from, hopefully from Expressive using Amazon. You have to be careful with Amazon.
Wired up on a breadboard, right? You just
No.
buy the two parts and wire it up.
Yeah, it looks like it's that, go back.
Right, it's the one we were looking at, it's the white one.
So it's this board right here.
So basically you order the two pieces
So you
and
get,
some
you
wires
get,
and
a,
stuff.
you get a
and
wireless
go.
breadboard, you get one of these for $10. And you get your personal preference on either, custom cut wires. These wires are all cut to be exactly the right length. But you can get jumpers. I'm preaching the choir here. Everybody in this meeting knows all about the male and female jumpers for wireless, for solderless breadboards. But Rob's point is that you only need to get what you need with this path. With the custom PC board, this is designed to go into a solderless breadboard and have full connectivity to everything that's available relevant to the FPGA on these pins, and everything that's accessible on the C3 is on these pins, except there's some magic connections on the other side of the board which you can't see. I can't remember if there's any additional functionality in this. Yeah, so these pins give you complete availability. So if your app, as you might expect, doesn't want to use this FPGA, you don't need to use it. And then we've got another generation of hardware called green boards. And this is pretty sparse. And it's got some old, forget that word, fire deck, that was half-baked. And we need a better name. So basically what this is a large 10 by 10 centimeter minimal size PC board that has the functionality that I just showed you from the purple board permanently on the green board. And then there are other pieces of the green board that have things like the analog devices, PMOD, quick connectors, SPI connectors, maybe micro SD card connectors, et cetera, And then there's this great big area in the green board that's uncommitted. And we implement the design of the green board so that the stuff that's fixed on the board is just a module, and the user's application slots into that and takes advantage of the basic services. And you don't have to populate those things. Like, if you only need the absolute minimum, you don't solder PMODs, you don't solder quick connectors on your board. That would just cost money, right? So it's designed to support a more enthusiastic design where the person wants to end up with a fully made system with no jumper wires, there may be jumpers for configuration, but you're not going to have a tangle of.
This is for the person who's comfortable soldering their own parts on, who
Oh,
take
yeah.
a circuit board and build it out the way we want, and they might even ask, can I have the keycap or whatever, because I want to drop into that unpopulated area. I actually want to add my stuff in there.
I have bad news.
Oh, okay, what's that?
This is Eagle.
Well, so I get Eagle, and then I can drop my stuff into an Eagle.
And let me dispel a few common misunderstandings. But you can get Eagle for next to nothing for a short period of time. And for, in my opinion, a very reasonable $100 per year. And you get the, current versions and all that stuff. It's an extremely mature product. But that's not to say
So
that we're not ignoring KiCad.
We're old
We-
and don't know
that
how to use
wasn't
it.
my
We
point.
are old and don't know how to use it.
That wasn't my point. So I'm agnostic for software package. My point was it's for someone who either is happy to take the board and solder it in, or someone who's happy to take the design and in WordPerfect, add in their parts so that they can have a circuit board that's actually, they can order off a circuit board that does their stuff too. Like that's sort of where this is aimed at.
And
It's
so,
a different audience, right?
exactly, we're talking about more and more sophisticated users.
And
And
The ones who can use WordPerfect to design the printed circuit board, they're very sophisticated, okay?
well, and then they get somebody like me to translate that into an Eagle module that plugs in and we send it
I'm just
off.
thinking that
we
you
send it off
WordPerfect
to
to create a
the-
file that Eagle can read.
you can, but it's,
We'll see, But then we have an extremely inexpensive vendor for PC boards. We're very, very, very lovingly attached to Osh Park in Oregon for prototyping, but for actual volume, especially at 10 by 10 centimeters, Osh Park is expensive. Does anybody know what? Well, who cares? I can't remember now. So I think it would come out to 30 to 40 bucks for 3 copies of this board from Osh Park, which you will actually do that depending on your situation, or you can use the Chinese vendor. There are two, there's one extremely good Chinese vendor that's been vetted by somebody who put a lot of effort into getting his thing. I published it on the TriNet email list recently, and he also raised he mentions what's the other one that's got way in there?
easy way.
PC. Is it PC? PCB way?
Um,
PCB way. I'm not as fond of them, but anyway, so this is kind of an overview of the hardware side.
the issue, several things on the over-the-air flashing is that the over-the-air flashing module is the same as the temperature module. It's a drop-in module. I guess it can have to drop it in here. Second thing is that I haven't done it yet, but I'm going to place an order at some point in the near future for 100 boards, do the initial flashing, and then send them off to Amazon. They will put them in storage in Atlanta and ship them. Pre-programmed. And send me
Then
or whoever.
somebody can order one that just works when it
Yeah,
arrives.
they can order one that works. It will work fine. And it's they're like $3 a piece if I order them from the kind folks in China.
And if they hit any level of popularity, unless we somehow block it, Adafruit or somebody else will say, "Oh, this is really cool. I can do that," and they'll just start doing it, and then they just are on the market, and it's easy, right?
Yeah.
Unless you're planning to pull a lot of money out of it, it may be easier just to, once they realize it's an exciting thing to sell.
Yeah, no, it's yeah. But having it listed on Amazon
Yeah.
is a trivial thing.
Yeah.
And Amazon takes care of all the taxes.
Everything.
They just they put it in the bin. The bin's marked for you. Some clown goes by, picks it up, throws it in the bag, and they get it the next day.
Robot, yeah.
That's a cloud robot. Arrives the next day.
Yeah, that seems good. And then the people who are in the place of, I need an AVR dude, don't even need an AVR dude, right? They just need, I got a module, it works. Now, where's the ebook I buy that walks me through this at my level?
Well,
How does that happen?
that is not going to be written by me.
Right, but the point is, we
Yeah.
have people here, if we get comfortable enough with it, we'll be doing that, I
Yep.
think.
And that's, it's and yes. But the,
Okay, I recommend, we've got 20 minutes left. I recommend that we loop back to the agenda
agenda.
and we got 50 clicks on that. There it is. We need to talk about this.
Well, Paul is going to do the, his,
You mentioned that. Right?
yeah, not only going to do a meeting, but he's going to do that little sensor for the horse thing. It's, and Dawn, I've got a sensor for you. So, it's, one of a number of sensors, it's, and I'll get you the actual sensor, and, if I can walk you through it, it's, just, I'll get you sensors, and, it's show you how to put together the modules, and it won't work because I'll do something wrong, or you get something wrong, and we'll scream and
Begin
shout
learning.
at them.
Begin learning.
Yeah.
And I've got, you can't see it, but I've got a $5 sensor from SparkFun. I bought the last saw. I got 5. I need 1. I gave, I sent, Jonathan's got 1. And it's a extremely high precision barometer thermometer. We're talking about detecting, moving the sensor up and down a few feet. It's designed for those little things with the props running around. Drones. It's designed for drones. The temperature side is working well. It's very, very precise thermometer. It does compensation with factory tuning parameters, but it's pretty straightforward. My barometer readings after compensation are coming out too large by a factor of 100. I've got another Bosch sensor board, and it comes out too large by a factor of 10. So there's a pattern there. And I've looked at this code 70 times. I've compared it with SparkFun code, blah, 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 but I'm getting off track here. If I've got 3 more boards, and if anybody is interested in pursuing this, and you can do it in about 3 steps, you've got at least 3 or 4 choices. You can, let me show you some code here.
And by the way, Jamie, you already have the LED stuff, so that you can start working on the LED interface.
LEDs with Azure.
Yeah.
All right, I'll message you.
Yep.
Okay, so I've implemented a sneaky interface, a sneaky set of apps. This is the Python code. Can't really see that. And this code sneaks past aardvark. It doesn't use aardvark. It talks directly to Ant. And it still runs on the PC with a Wi-Fi connection to the ESP32, but it talks through HTTP commands that are sent via an interface that basically says, show me what kind of resources the resources are exposed. It's a REST interface, and it calls, some of you have heard of HTTP get and set. There's also patch, which is a combination of set and get. It basically allows you to get to send a modification of a set of defined resources, and then get back modification that Ant has made, and you get back. You basically send a command and get data. Is what it comes down to for this function, and then this function down here. Did I overrun it? Just a minute. Okay,
Shouldn't you be using mix things?
Well, of course I should.
Vendors?
Do you think it works? Hell no.
Okay.
Next stuff doesn't work yet. It doesn't work yet.
Wait.
And it's a
Can you bring
RESTful
up your
interface,
intervention?
and he's using the RESTful interface, right?
My version of Azure.
Yeah, can you bring it up?
Yeah. Can I bring it up? Didn't I just have to?
Yeah, you just had it.
I just have to click
Yeah.
on this to start it. And anyway, to finish my spiel, I've got a way to see the sensor work with Ant immediately. And when Aardvark is ready, as Nick described earlier in the meeting, the two of us are going to arrange an official class, bona fide plugin for Aardvark and Ant, so that you can see it using the
Guys, just to let you know, we got about 10 minutes before I gotta kill the recording.
okay.
Click on the graphing function.
Now what do I do?
Okay, that was it. I didn't know whether it was still working. That does temperature probably.
Right. So to add to what Nick said earlier, we're going to make the official last thing, and that's going to be a model of how you develop the specific modules that go into AMP and modifications, or I should say, well-defined modules that layer onto the existing AMP and Aardvark code. So we can demonstrate this sensor, and he's got a mechanism that ties it right into a graphing function. So you can watch your temperature and barometric pressure, which can be expressed as altitude, by the way. And so that's an opportunity for up to 3 of you or your friends to get involved with this thing. And the natural starting point is to suffer through the current install process as we thrash around about how we would like to see the install process for development. We're no longer talking about end users that just want to be appliance operators that want to use a pre-existing thing. We're talking about folks making the support for the additional devices. The starting point is, of course, to get Edge running on your PC. I think that we have a reasonable mechanism. Dawn's problem was the fact that she's got a CLI interface with WSL. She's got no graphical interface. So it's really hard to run a web browser with Aardvark inside of it from a CLI interface, command line interpreter interface.
No, I've done that. But
Oh, she's done it.
It's only the icons. I can't click on icons because I don't have a desktop.
Right, you can fire off with the icon when it fire it off, and then it all just works.
Oh, yeah, okay, good.
You cap the desktop file, and there's the command you need.
Yeah,
Yeah, I
Exact-
know, I
the
just
exact
did that,
line of
right?
this. Okay,
Well,
fine.
not yet. It was late last night when I realized that.
Okay, great.
No, I've run Editor before
Okay, great.
from the
And Jonathan has started on that. And I believe some of you have the Linux thumb drives. So you can bring up this same, if you bring up the Linux thumb drive, it gives you exactly this in a vanilla Ubuntu Linux setting. And those of you who, as we said, if you need help, we're ready. And some of us are,
Yeah, more ready than others.
well, some are more ready than others, but some are becoming ready to help each other as they gain experience. So, that's interesting. I don't see that blue rectangle. That's really strange.
Oh, that's probably, is that on me? Oh,
Yeah,
yes.
that's yours.
So you're running out of battery?
Probably. I can plug it in real quick.
Okay, so, to try to wrap this up, we're looking for folks now on a couple of different tracks. One track is to take an assignment from Nick. Here's a sensor, like he's doing with Dawn. Here's a sensor. I want you to work through support for this. And another track. You guys still hear me?
Yes, we can hear you.
Okay, because she's fiddling with her laptop.
No, I just started the recording, that's all. On this end, Carl and I had talked about handing it off, that's all. So I'm trying to.
Okay, well, we really have to leave. I have to.
Go ahead and finish.
We're gonna drive 5 hours. So,
Tonight?
those of you who are interested in progressing with this, make yourself known, what your areas of interest are, what you'd like to do. And, I guess I already mentioned that Jonathan has started on investigating installation and so on. But we're looking for connecting with users now. Users at there will be some of you who don't want to get involved with the development aspects at all. But there are other things that can be done that you can get involved with, especially using the existing code from a purely user standpoint and going through and saying, how come this doesn't work? I've clicked on this thing, and according to the architectural document that doesn't exist yet,
That's why it doesn't exist.
waiting for a writer, if I click on this, it should be turning green or exploding or something. It's not working. We need people to systematically go through and prove out the actual behavior of the system. So we've got 4 minutes left, and I'm going to shut up.
I'm waiting for the thing to download from Azure Guide
And so am I.
before I jump in and start reading.
I could,
Because I'm on Windows.
exactly, I could arrange, I think I could arrange to build that for the current release.
That's what you're
We
running.
actually work with that. This assignment you have given, can you do it with the current release?
Yep.
Okay, so I should be able,
Yes,
well,
you
in
can.
fact, actually, Carl needs to get involved in this too. To add that extra step that spits out the distribution. And I'll take that as an action item. DIST. We demonstrated that last month, and the directory might actually still be there. I'm not sure where there is. I don't remember if I put it on Prime Bed.
We'll get you.
But
The
I'm burning up.
video from last month was very hard to understand, and anything you displayed on the screen was impossible to see.
Exactly. I mean, I think but here's the interesting part. If you go to edger.app, where's my browser? Perhaps. Oh, here it is. What the heck? What happened to my browser? If you go to this website, you click on edger.app, and then where's that? What did I do?
We're running out of time.
But you have it there, just download that.
Just go to this using Edger with the Dev2 board and click on the PDF. There's a PDF somewhere.
At the bottom of the window is a download button.
Bottom of the window. There you go. So download this. And this is an extremely detailed how-to. And it covers the case where you've got a thumb drive, and it covers the case when you don't. And it's step by step, and I believe that's what you use.
Yeah.
So with that and the disk directory, I think Paul can proceed.
Okay, guys, I've
All
got
right.
Phyllis.
Okay.
Done.
Bye-bye, Carl. Thanks so much.
You're welcome.